All right, thank you for the introduction. Thank you to NordSpace for having me here today. My name is Andrew Ronan. I'm co-founder and CTO of Ronan Space Systems. We're a very new startup based in Vancouver, developing robotic systems for the exploration of the moon and Mars. But we also offer consulting and design services to the launch industry, which is what I'm here to speak about today. So I'm going to share some of the lessons that I learned during my time at RocketLab in New Zealand, where I got probably the world's best crash course in how to efficiently build launch infrastructure, but also a launch industry. During my time there, I built one launch pad in the United States, and as well as one in New Zealand and a propulsion test facility in New Zealand. We also launched a lot of rockets. And if I could share one piece of advice with everyone here today, it would be don't just copy the Americans. The New Zealanders definitely have a lot figured out as well. I'll also share some of my experiences in the subsea industry, as well as the challenges of bringing a product to market in Canada. So I'm going to focus on 4 lessons I think that Canada could learn from New Zealand, or should learn from New Zealand. 1, how to move with speed. 2, what supportive funding looks like. 3, how we can right-size our regulation. And 4, how we can find the right people to build the industry. So what was the first and foremost thing that New Zealand did right, I think, was to formulate a strong national strategy, their government did, and then they moved very fast, uncomfortably fast. So in 2013, when RocketLab raised its first funds to develop their Electron launcher, New Zealand didn't have a space agency. They didn't have a space industry whatsoever. And then in just 3 years later, in 2016, the New Zealand government had created the New Zealand Space Agency. They had a TSA in place with the United States for the exchange of technology, and an interim agreement that allowed RocketLab to commence launch operations. And then just 1 year after that, New Zealand passed their space legislation, new space legislation, and RocketLab conducted its first successful launch. That means the government of New Zealand responded to market demand in just 4 years, which is uncomfortably fast. We can look at Canada as a comparison. In 2023, Transport Canada announced the government's commitment to support launch in Canada and to modify our existing regulatory framework. So that would take us to 2026. And we have a TSA in place with the United States. So that would mean in 3 years, we've modified our existing regulatory framework and have a path to launching, whereas it just took New Zealand only 4 years to get to orbit. But it's not all that bad. If we can commit to a launch in 2027, we would be 10 years behind New Zealand, but we'd be in the fight, and we could start to make up ground. 2, let's talk about funding and reliable customers. So the United States government was a very reliable customer for RocketLab's Electron launch vehicle that helped them commercialize their launch product. But we have something called the second value of death in product development. It's where technology reaches a high TRL level, but it fails to commercialize. And Canada's good at that early innovation step, but we do struggle with that second value of death. If we look at the subsea industry for an example, Canada has developed 2 autonomous underwater vehicles in the past, but they failed to be commercialized, and we're currently developing our 3rd. But if we look at Norway as a counterexample, the Norwegian government also developed an AV around the same timeline, but they also had the follow-through to deploy that into their defense, their commercial, and the research industries. As a result, Kongsberg Maritime now dominates the autonomous underwater vehicle industry. The same strategy worked in their space industry, where Kongsberg satellite program, KSAT, dominates the ground-based satellite telemetry network. If we come back to the launch industry and we look at the largest commercial launch providers, about 30% or 3 of their first 10 launches were government funded. And that's important because, as we heard earlier, it gives confidence to investors and also to commercial customers. It helps carry them through that second valley of death into commercialization. And those funds, that funding commitment, it goes a long way. So it obviously supports the launch providers, but it also supports their entire supply chain, as well as their customers, like satellite manufacturers, spacecraft manufacturers, like Ronan Space Systems. And that cost of launch can be a high barrier to entry for their customers, like Ronan Space Systems, who need to launch to orbit in order to validate our products. So the Canadian government could see this as a force multiplier, where if they did commit to funding 3 of the first 10 Canadian launches, They could offer slots on those launches as ride shares to academia or startups, and would let us put those CubeSats and prototypes on orbit instead of on shelves. So the US government helped carry RocketLab's launch program through to commercialization, but the government of New Zealand did the same for their spacecraft manufacturing business with the funding of their MethaneSat program, which carried RocketLab through that second valley of death, allowed them to vertically integrate into spacecraft manufacturing. Third thing I want to talk about today is regulation. There's a lot to launch regulation besides just launch licensing. There's a reason a lot of engine test facilities are relocating to Texas. They'll let you do basically anything in Texas as long as you put a fence around it. But I want to speak a little bit about how regulation can impact spacecraft. So take this spacecraft as an example. It has hydrogen on board. It also has industry standard flared fittings. By current Canadian regulations, it is illegal to use flared tube fittings on hydrogen systems. So this spacecraft would be illegal to use in Canada. If a Nord Space customer wanted to launch this spacecraft, they'd have to obtain a waiver, which can take years. They would also need to obtain, somewhat unique to Canada, a Canadian registration number for every pressure-retaining component on board. And in Ontario right now, it can take up to 96 days for a single CRN, which these timescales just don't work in the space industry. So if Canada wants to catch up and make ground, we need to modernize our regulations or figure out how we can move faster with the existing regulations. So what did New Zealand do well? Well, first, they've nationally adopted the ISO standards, which opens up a large supply chain through Europe and pool of subject matter experts. They also have a program for delegation of review and inspection steps to third parties, which takes a large workload off the government. It also eliminates the requirement for the government to have a large pool of subject matter experts, which can be challenging in this niche industry. And the last point I want to speak about is how we find the right people. So it's actually not all about rocket science. I came from the subsea industry. In less than 2 years at RocketLab, I became a high performer. I think I'm great, but I think that's more of a testament to the transferability of my skills. You can look at Peter Beck as well, the founder of RocketLab. He's not a rocket scientist by training or by experience. He started out as a tool and die manufacturer at a appliance manufacturer in New Zealand. So where did RocketLab find all of the rocket scientists if they didn't have a space industry to start? Well, they looked to complementary industries. So for pad systems, they pulled from oil and gas and their dairy industry. For the launch vehicle, aerospace, auto sports, and boat building. It's not a coincidence that their Electron launch vehicle is an entirely composite vehicle when New Zealand's carbon fiber boats keep winning the America's Cup. New Zealand also has a really fast and simple immigration process. It let RocketLab draw top talent from other countries around the world. When I joined RocketLab in 2018, the team was about 10% Canadian. So what can Canada do? Well, we should also look to complementary industries and cross-train, and we should work to bring that Canadian talent home to Canada. So as a recap, what are the 4 things that I think we should learn from New Zealand? 1, we need to learn to move with speed, and I think we can show that by committing to a launch in 2017 and starting to play catch-up. We spoke about funding, what supportive funding looks like, which I think should be the government of Canada committing to funding the first 3 of 10 Canadian launches in Canada. How we can right-size regulation by adopting more global standards and simplifying our waiver process. And how we find the right people by leveraging complementary industries and bringing Canadians home. So my time's almost up. And I could speak on this topic all day. We actually have a longer version of this presentation that we'd be honored to give to anyone at the Government of Canada that'd be interested to hear it. Ronan Space Systems wants Canada to have a launch industry. We want to see it thrive. We're here to support. We would love to see one of our rovers fly to the moon on a Canadian launch vehicle, launch from Canadian soil. And yeah, we're here to help. So if you would like to connect, myself and my co-founder Sarah will be here all day and this evening's social. Come reach out to us, grab some swag that we have here. You can also scan this QR code to find my LinkedIn profile and connect that way. So thank you everyone for joining, and I think we've got time for some questions.
Hi, thanks for the great talk. So your experience with RocketLab, you've kind of thought through the idea of rocket reusability. Should we be targeting that in Canada as our initial launch vehicles, or put that on the roadmap for the launch companies?
Yeah, great question. Reusability. It's definitely something that SpaceX has shown us can really drive down the costs. If you don't have to rebuild a launch vehicle every time, it obviously saves a lot of time and money and resources. You can see with RocketLab's approach, it started out with a completely expendable booster, tried recovery with the first stage, seemed to have parked that. That was actually a program I worked on a fair bit during my time at RocketLab. But now their Neutron launcher is aimed to be fully reusable, and you're starting to see even upper stages being reusable. So I think it's an important step to drive down those costs, which is going to be a big piece of what helps this industry stick around and become more commercial. But it can drive you to overcomplicate designs early on. So it should probably be considered, but not necessarily a hard requirement for early launchers. Thank you.
One or two more questions.
I think we've got one in the back here.
Can you raise your hand very high? Okay. Yep. Getting my workout in at the same time.
Dave Beck from Space Force. I'm also came from submarine. I was a U.S. Navy before I came over to Space Force in its second year. One of the things I look at from SpaceX, which I'm not a fan of, I'm not a fanboy for SpaceX at all, I just want to say that up front. A recent mission we had, which is part of an organization I sit on board with, is National Digital Foundry. We had one with Exo Launch and Transporter 13 with SpaceX. There was 70 different companies and industries from around the world. I want to bring this up. They were on that mission. That's the reason why SpaceX can charge that low amount of money, because you got 70 different payloads attached to that one main module that are delivered to orbit. And I would say, from Canada's perspective, when we start launching in 27 and beyond, use the same perspective. There are several companies in the U.S. doing the same thing, so the technology is not expensive to adopt. And I'm sure Ronan can help with that as well, to launch some of these capabilities, but use a collaborative effort of people in this room, including the great company who put this together today, sitting over there in the corner, to build some of the capability to put on that launch and launch it. That would be extremely valuable to the ecosystem for Canada going forward, and also a good way to do research development in space for companies who are looking to expand in space.
That's a great point. And it's something that we need to definitely work together as an industry, not just sharing our capability, but also a lot of the facilities that we're going to need to develop. Like a world-class space testing facility just closed recently on the other side of Ottawa. We will need to build that capability in the commercial space as a replacement. That can save a lot of time, resources. We don't all need to buy vacuum chambers. We don't all need to buy vibe tables. We can collaborate on both ends of the spectrum, and I think we need to if we want to keep up, and especially if we want. I would like every component on our vehicle, our rover, the launch vehicle, to be from Canada. I think that's important. It's only going to happen if we work together. So great point. I think we've got one in the back.
Hi, I'm Jesse, also ex-RocketLab here. So I wanted
Cool.
to ask you,
Let's catch up later.
from your experience, what lessons, if any, have you learned about back-end software systems, ERP, inventory management solutions, and what might you do in your own company?
That's a great question. And I think, so ERP, enterprise resource planning, the tools we use to buy and manage inventory when you try to scale to the point of mass production, it's another, I talk about the second valley of death. The transition from you've made orbit, your first rocket works, the design is done. How do you then start mass producing? That's a very painful transition. SpaceX struggled with it. I was there at RocketLab when they struggled through that. Software tools and automation is a lever you need to pull. I've seen the other end of that, where companies try to adopt too much structure and automation early, and it chokes out all the innovation. If it becomes too hard for engineers to buy things quickly when you're trying to innovate, you lose all that creativity. So it's a bit of an art, choosing when to go fast and when to be meticulous and be able to push a button and buy an entire rocket. So I would caution not to do it too soon. But again, you need to understand the direction you're going so that you can plan for that and put in the hooks early, plan for it early. But I would, caution against too much structure too soon. Good question.
So that's all the time that we had for this talk, but thank you very much, Andrew, for your time and the conversation. Okay, so I'm hearing some